Hi everyone, welcome to our event. This event is brought to you by DataTalks.Club, which is a community of people who love data. We have weekly events, and today is one of such events. It's been a while since we had our last podcast interview. I think it was in June or July. Yeah, so we had a summer break. So now we're finally, kids went to school today in Germany, at least in Berlin, and we are starting to continue our interviews and other events. So welcome everyone. And if you want to find out more about the events we have a few in our pipeline. In particular, today I will host a Q&A stream about a course we start in a couple of weeks. So if you want to see all the events we have in our pipeline, there is a link in the description. Go there, click on that link, and you'll see the events we have. Then, of course, if you have not subscribed to our YouTube channel, do it now. So there is this subscribe button. I think I need to update this number here because it's almost 50,000, right? Anyways, last but not least, do not forget to join our Slack community. This way you'll, what I usually say here, you'll stay in touch with other data enthusiasts. Yeah. So usually I remember this from the top of my head, but it's been a while. I need to revise what is actually the script. Anyways, you can ask any question you want. There is a pinned link in the live chat. Click on that link, ask your questions, and we will be covering these questions during the interview. And right now, I am going to stop sharing my screen. I will open the questions we prepared. And yeah, one thing before we start, I want to make sure I pronounce your name correctly. It's Rachel?
Yep, Rachel.
Rachel. Okay, Rachel. So let's start. So this week we'll talk about using data to create livable cities. And we have a special guest today, Rachel. And Rachel is an urban data scientist who's dedicated to creating livable cities through innovative use of data. And excuse me. Yeah. So welcome, Rachel, to our interview.
Thank you. Hi. Happy to be here today. I've benefited greatly from the Data Talks Club's courses, and I'm happy to be here to share my experience.
Yeah, we're happy to have you. So let's start, before we go into our main topic, let's start with your background. Can you tell
Yep.
us about your career journey so far?
Yes, I am currently working as a data engineer in Singapore, and I'm dedicated to creating livable cities through the use of data. I combine my background in geography. I have a bachelor's in geography and a master's in urban data science, where I blend qualitative and quantitative analysis to tackle urban challenges. I started my career in data science, applying my skills in analytics and machine learning to various transport problems. Projects I have worked on include bike sharing analytics to curb indiscriminate parking, as well as road defect detection using computer vision. And through these use cases, I've had the opportunity to make a real impact in cities. And the satisfaction of seeing my work leading to tangible solutions motivated me to become a transport scientist, where I focus on analyzing travel patterns to shape long-term planning in Singapore. And to further enhance my impact, I recently transited to data engineering after taking on the Data Talks Club data engineering course. And by diving into data foundations and building data platforms, I ultimately aim to optimize AI applications for creating livable cities.
Hmm. Yeah, amazing. So how was the course?
It was good, really. I think it dove into a lot about building data pipelines and using Mage
Hmm.
as well, which was quite an eye opener. And I think it was quite relevant in helping me transit into this current role that I'm in.
Hmm. You said you were a transport scientist, right? Did I
Yes.
hear the name correctly? So what do like it's not so for example, used to work at an e-commerce company. There was not such a role as transport scientist. So I imagine there are certain types of institutions that need this role. So I'm wondering what the role is and who actually needs transport scientists.
I think predominantly in the government sector where I'm working in, where we do transportation planning, and really transportation scientists is combining data science but doing it in a very applied manner in the public transport or like transport planning field. Another field I would imagine would be transport consultancy, for example, like Sam Schwartz. Yeah, so I think these two key fields mainly,
Hmm.
but really it's about applying data science in a urban context.
Hmm. So which means like planning where to put bus stops or how often buses should go or things like that.
Yeah, that's part of the things, but we
Hmm.
we separate it into more short term and long term planning. So in the short term, we look at bus routes, we look at frequency, what is the travel patterns, how are the services holding up, like how well is it serving the transport users, and in the long term, we also use um, travel patterns. We do projections and use this to do long-term planning in the form of whether additional roads would be required, whether
Hmm.
additional rail lines would be required, and what would the alignment be.
Hmm. Interesting. So I guess so let's say there are a bunch of buses in Singapore. Each bus, I assume, has a sensor, right? And you track this, you track delays. You also track how many people are on that bus, right? Things
Yes.
like that. And through with this information, then you can see, okay, like this bus is always occupied. Like there are too many people in the bus. Maybe you should go more often, right? Things like that.
Yes, for sure. There's a
Mm, interesting.
combination of data that we look at. So we have transponders on the bus that tracks the location of the bus by GPS. So this way we know whether there are the buses, what time the buses are reaching the bus stop, whether there are issues related to bus bunching, which is essentially two buses of the same service number hitting the same bus stop at the same time. So
Mm,
this way, ideally, we will want it to be spaced out in a frequency rather than having multiple buses reaching the same stop at the same time. That
yeah.
way, we are not really optimizing. The
Hmm.
other side of things would be so that's more of like the supply side, and more from the demand side, we look at fare cut data, which we track where people are tapping in and tapping out. So this way, we get a better sense of travel demand.
Hmm. What do you mean by taping in and tape out?
So in Singapore, we use a fare cut data. I think in many cities, like for example in London, you have the Oyster card. In New York, you have the Metro card. So in
Uh-huh.
Singapore, we have a fare cut system as well. So
Hmm.
going into a public transport system, whether is it going
I
into a
see.
train station, you would have to tap in, and when you get out, you have
Hmm.
to tap out. Same for
So
buses.
you have a card, and then there is like some sort of reader, right? And
Yeah,
you,
it's
I see.
contactless. Yeah,
Uh-huh.
contactless transport.
Yeah. Interestingly, in Berlin, like people can just hop on a bus without doing anything, and then just sit and like
Yeah,
sometimes there's control, sometimes there's not, and
yeah.
I,
But
I
this
wonder
way,
if they
you
track
you don't get
anything.
to collect the
Yeah, right.
information.
Oh, maybe like there are cameras in the bus, but it makes the collection process way more difficult because you need to like look at the data at the videos
Yeah,
somehow
then you need
and
to apply
count
computer
people.
vision on it.
Yeah, instead of just looking at the events and then doing count and that's it. Interesting. And what did actually motivate you to uh, work on this intersection, on work on geography and data science?
Mm, Growing up in Singapore, I was very fascinated by the intricate systems that shape cities. And I also witnessed firsthand how Singapore developed from this. We had this very rapid expansion of the MRT network, as well as the development of new housing estates. And I became very intrigued by these forces. So this motivated me to go more into the study of geography. And
Hmm.
on top of that, I did an internship in the Center for Livable Cities, which deepened my understanding of the complexities involved in creating sustainable urban environments. And through the internship, I also had the opportunity to attend the World City Summit, which was really inspired by a global community that is united in the pursuit of creating better cities. So through this summit, city leaders from all over the world would come together and share ideas on how to make cities better. And then I began my academic journey focusing on geography. more specifically focusing on urban design, geocomputation, as well as geospatial analytics. And then this led on to quite naturally actually going more into data science, which I then pursued a master's in urban informatics at New York University. So it was a course that specialized in applying data science in the urban context. So this
Interesting.
kind of led me into my current role.
Mhm. Yeah, because like my views on what I know about geography is super limited because it's limited to school. And at school, we were mostly studying like what is the capital of what, and things like that. Different, I think, types of. I don't even remember like oceans and whatnot.
Tectonic plates
Yeah,
above
yeah, yeah,
volcanoes and
exactly.
earthquakes, right?
Like, and
Yeah.
I wasn't the best student, so like this kind of passed by me without staying in my head much. So yeah, that's why for me it's always interesting to know like what actually geographists do. And then you mentioned one of the things is urban design, which I guess means like, okay, we need to maybe build a new district, right? And then some houses, and then of course there should be a school, there should be kindergarten. How large should be the school, or how many schools? This is things like that, right? So this is what you mean by urban design, or
I think
it's something else.
it is that, but on top of it, to design it in a way that it is um, livable for people to live in. So
The
how,
parks.
yeah, parks. How do you make streets more walkable? How
Uh-huh.
do you design streets, like certain width of streets? How do you put like a side? Where do you put a sidewalk? Do you add another like row of like planter boxes around, keep it away from traffic? Do you make a area safe? How do you make an area safer? And how do you make people want to linger on the streets rather than just walk through it? How do you create communities through the design of streets?
Mhm. Interesting. Why is it called geography? Like, what does it have to do with like all the things we studied at school? I'm
Sorry,
just curious. No,
what
I'm
was
just
your
curious,
question?
like, what does it have to do with like all the things we studied at school? Like, why is it still called geography? Like, why is it a part of geography? That's what I'm wondering.
I think geography beyond the physical sense, there's also the human aspect of things. So in the physical sense, includes things that we study in school like plate tectonics,
Mhm.
about volcanoes and earthquakes. But the other side of geography is about the human geography, where we study things like people migration, population changes, and these are things that we see around us every day. So I think that's what makes geography so fascinating,
Mhm.
because whatever you study, you see it happening in the real world, and things that you do can directly feedback into changes.
And yeah, so I was just taking notes of things that we talked about. So we talked about like things that make a city more livable, which are parks, like different lines for pedestrians, for cars, traffic signs. And then you also mentioned communities, like somehow you want to create space for people to feel like that they
Yeah.
belong, things like that. So, what else do we need for a livable city? Like, how would you define a livable city?
To me, a livable city is a place where people feel connected to their community and have the opportunities to thrive. So, physically, in the built environment, this can translate into a multitude and combination of things. So, firstly, more like efficient public transport, where you have a well connected network of buses, trains, as well as bike share programs and pedestrian friendly streets. Um, Good, safe and cycling and walking infrastructure, where we could see dedicated bike lanes, pedestrian walkways, and crosswalks. Infrastructure that can accommodate to different needs, such as people with disabilities. It can also translate into affordable housing, proximity to amenities, where homes are located near essential services as well as green spaces. So all this creates a built environment where people feel safe, people can connect to their neighbors, and people are happy to live in essentially. And I think beyond this, increasingly it goes beyond the physical infrastructure space and to also the digital realm in the form of a city with strong digital infrastructure that supports the needs of its residents and businesses. So digitally, it could include things like online access to government services, digital safety, and being able to connect residents on digital platforms as well, since we now know that a lot of people are actually spending more time in the digital space. So there's a need to merge these two spaces.
How well is Singapore doing when it comes to livable city? I must admit I have never been to Singapore. I want to visit it at some point,
You should
but
visit.
I definitely should, yeah. But like how well, how livable it is, how would you say?
I think we have grown a lot over time. Essentially, we had a phase whereby we were very focused on growing and developing housing estates, and increasingly there's a lot more focus on placemaking, creating spaces where people can linger and enjoy. And also we have a movement whereby we are converting streets or districts into car-free zones. So this increases improves the environment for people to walk, to cycle, and we are also creating dedicated bike lanes. So I think it is a journey. There are parts of the cities that are better, more livable than others, and we are working on it to make more spaces like this.
Mhm. Yeah. And what's unique about Singapore is it's geographically quite small, right? So,
Yes.
and it's very densely populated. So you have to be very, how to say, effective about how you
Mhm.
use land, right? That's
Yes.
why you need to think about these things.
It's a very conscious planning process. And land planning in Singapore, there's this process called master planning where we plan ahead like 15 years in advance, so we know where certain amenities should be, how do things come together across different time points.
Hmm. Okay, interesting. Because like I was thinking, since I live in Berlin, of course, I was thinking like how livable it is. I think it is doing pretty well. Like there is good public transport. I wouldn't say cycling is really great here. There are areas where there are more um, bike paths. There are areas with fewer of them. Like, and I can compare it to Moscow. For example, in Moscow, for people with disabilities, it's super difficult to move around. Like in Berlin, I can see quite a few of them on the streets. So the city is pretty accommodating, and that's amazing because I actually like did not think that this is actually I think that people study and then go implement, and then actually it's not just how to say it's very practical in a sense that there are data scientists, there are data engineers. So I'm really curious to know what you do, what you did there as a data scientist or transport scientist, and what you do now as a data engineer.
I think in data science and transport science, planning for a city requires very deliberate effort, and data science can play a very pivotal role in enhancing the city livability by providing valuable insights and enabling it in a data-driven manner. Because by by leveraging on the data that we collect in different parts of the city, we can know where to optimize, where we can improve, and then lead to better public services and environmental sustainability. So in Singapore, we collect quite a bit of public data, and we also share this openly on open data platforms. So this allows for citizen developers or students or research bodies to leverage on the data, and there's some cross exchange of ideas. So public data in government agencies, we collect things like transportation data, like fare card data as mentioned before, as well as census and survey data. So using this information, we can be better able to understand travel patterns, and this translate in the long term. When we do population projections, we can also use this information to project future travel patterns. by knowing where people are moving, we can then plan out and conduct transport modeling to see what would be the possible alignment of rail lines to bring people to places that they need to get to.
Mm-hmm.
And increasingly, actually, we are also collecting data from private sector, which includes things like mobility data from ride sharing apps. So this gives us a picture apart from the public transport perspective. It includes information on how taxis are moving, how are ride hailing apps, how are people moving using like ride hailing.
Mm-hmm.
So this kind of gives us a glimpse of another dimension of people
Mm-hmm.
movement.
Okay, and this is interesting because you said you also want to predict where people will move, like, which means, if I understood correctly, let's say people are moving from one part from Singapore to another slowly. Maybe there is a district that is more conveniently located, and there's it slowly this district is slowly getting more populated. So you want to predict these patterns and understand, okay, because there are more and more people who live there, we need maybe a new bus line, or this bus should go more often now. Things like that, right?
Yes, something like that. But from because Singapore is really small, so
Mm-hmm.
we plan out how housing estates would develop over time, whether
Mm-hmm.
is it through a new injection of a new housing estate, or whether is it housing renewal whereby we
Mm-hmm.
rejuvenate a certain area. So this way we know how many people are living in a certain district, and from there we can rely on past travel patterns and new modes of transport to predict how will people be moving
Mm-hmm.
in the future potentially. So it's a projection, but we can use that to plan ahead. Whether is
Mm-hmm.
it for new bus lines, or for new bus lines, if we put in a new housing estate, we will need to make sure that it is connected to the rest of Singapore. So then the new bus lines or new bus stops location would be planned out that way.
Mm-hmm. And I know as a data scientist, like you cannot do much without data, so data needs to be there. And all this
Yes.
data that you mentioned, like sensors, moving patterns, ride-hailing data, like it has to be there for the scientists to use and actually discover patterns and then give suggestions. And this is probably the most difficult part, right? So like buses need to have like all the sensors, like all the physical means of collecting the data. And then from there, it needs to go, like the data needs to go to some platform where you aggregate it, somehow process it, and then put it in a table, perhaps a data warehouse where data scientists use it. Can you, like you as a data engineer, uh, are probably doing these things now. So can you tell us more about what's happening there behind, under the hood?
Yes, we ingest a combination of data. So from ride-hailing companies, we collect all this GPS location. From public transport data, we also collect the tap in and tap out information as well as GPS coordinates. So in our data pipelines, we have a end-to-end pipeline whereby we aggregate all this information, store it in a data warehouse, process it in a way that is suitable for data analysis downstream. So this allows us to have information across a long period of time, because for data science to work, we do not just need real-time data, but rather in order to do projections, we need data across a long period of time. So this allows us to track patterns over time, which is very important to have stable information and reliable data in that sense.
Mm. Do you also need the other also use cases where you actually need real-time data?
Um, for real-time data, it's a lot more for managing operations. So for example, if we want to know how reliable services are, then real-time data would be a lot more important. Um, One potential use cases is also for the tracking of traffic flow during specific events. So in Singapore, we host the F1 night race. So it is because it is a street circuit. parts of the roads are closed off. So we need to know how our traffic flow around the area being impacted. So we
Mm-hmm.
use taxi data as a proxy, because through that we know how fast the GPS coordinates are moving, whether there is congestion on the ground. So this gives us an additional, it's one of the data points that give us information on what is how traffic flow is like on the ground when we host large scale events like that in the city.
Mm-hmm. And what happens if there is a traffic jam?
It depends. So if the traffic jam is happening on an expressway, we have cameras on the road that track this incident, so we know exactly where it's happening, and recovery services will come in to either
Mm-hmm.
tow the service away or to
Mm-hmm.
manage the situation on ground.
Mm-hmm. So like maybe policemen to handle the traffic, right? To arrange
Yeah,
it. Mm-hmm.
combination of traffic marshals and also services to remove the blockage so that
Mhm.
traffic can
Yeah,
flow again.
right. Do I'm just wondering now, like I know in Berlin it's pretty common to do some sort of running events like half marathons, marathons, where they block like a large street for
Mm,
half a day, and then like it's probably quite inconvenient for the drivers because they need to find a different route. And
yes.
because these events, like half marathon or marathon, the distance is quite large, like it's like 21 or 42 kilometers. It means like a large, very large road or multiple roads actually have to be blocked. Do you do anything like that in Singapore? Must be a
Yeah.
nightmare for like for you to organize these sort of things.
Similar as well. We host marathons, we host like races in Singapore.
Hmm.
So for marathons, actually, we host it on a combination of roads. We do close off some roads, but
Hmm.
actually we have a network of park connectors in Singapore,
Uh,
which connects different parks. There are places that are actually completely free of vehicles. So
that's
most
amazing.
part of most part of the marathons can be conducted through like the network of park connectors and
Hmm.
some portions of roads. So actually
Hmm.
the impact of these events on traffic is not as significant.
Hmm. Okay, so this is what it actually means for a city to be livable, right? Because these things are thought through. And like, of course, if there are parks that are connected, you can run without like ever stepping across like having to wait for a traffic sign to go red or go green, right? That's
Yeah.
amazing, and that makes a city definitely livable. Because I'm into running. I run sometimes, and finding a route that does not have any like I don't need to wait for a traffic light, right? Or I don't need to cross a road. It's not that easy. Uh, yeah, so that's pretty cool. Uh, do you take part in any of these things, or you mostly take care now of transportation?
In managing these events.
Yeah, yeah. Like your role right now, you probably so you used to be a transportation scientist, and now you're a data engineer within the same area. You also work with transport.
Yes, I still work in transport, but I'm working a lot more on data prep, data pipelines on the upstream portion, and also increasingly um, finding ways to enable generative AI in the space
Mhm.
of data engineering, whether is it to allow users to query databases without actually having knowledge of SQL, for example.
Mhm. How often is it needed?
Eh, Often as data engineers or data scientists would get requests from users to
Yeah.
either extract data or help
Mhm.
perform a certain analysis. So it can happen quite frequently. So hence creating tools to enable users to extract insights on their own would be would help free up data engineers time to do other
Mhm.
more
Yeah.
innovative things. And
Hmm.
actually I always believe that data science or analysis should come from the users, because they
Hmm.
have the best idea of what do they want. Essentially they have clarity on the problem statements, and a lot of analysis will need to be will require formulating well-defined problem statements with a clear
Hmm.
purpose before diving into deeper analysis.
Hmm.
And when this gets transferred from like person to person, sometimes the real essence of what you want to find out could be diluted. So problems need to be effectively framed in order for it to be solved effectively.
Mhm. And who are these people who don't have SQL knowledge but need to get this data? I assume they are like subject matter experts who are not
Yes.
necessarily super technical, right?
Yes. Yeah, subject matter experts. It could range from like people that work in policy. They need information in order to come up with data-driven policies, for example.
And the policy could be, can you give an example of policy?
Um, it could be like how, for example, for like fare card information, or things like how do you adequately um, price transportation?
Hmm.
How many people are using concession cards in order to know whether a policy that you roll out, how effectively is it being,
Hmm.
how effectively is it affecting the end users?
Hmm. What is a concession cut?
A concession card is a fare card that gives you discounts. So like
Hmm.
in Singapore for senior citizens or students, you pay a
Uh-huh.
lower fare. Yeah.
Hmm. Okay, I see. So, like a question could be, what happens if we now make the price higher, right? Or come up with a new ticket. So, for example, in Berlin, there are bundles, like you can buy
Mm.
4 tickets and then it's cheaper. Like maybe a question would be like to get the data to analyze potential impact of a thing like that, right?
Yeah, in Singapore as well. So we have things like monthly passes that
Hmm.
gives you like unlimited travel for a certain price. So these are specifically for their passes specifically for students. So like we possible questions would be how many students actually use these passes? How
Hmm.
effective are they? Does it how what's the percentage of students that are
Hmm.
using this?
Hmm. Because they need to actually touch this thing to tap in, right? You
Mm-hmm.
have all this data,
Yeah.
but what this policy specialists do not know is how to query this data, how to get the
Yes.
data they need. Okay, and what you do is you probably have some sort of like chat interface where they can just type in the thing and then it gets translated to a SQL query and they get the answer, or how does it work?
This is something that we are looking to build. I think we're not there yet. So there's a lot of effort currently to help extract information or like do analysis. So this is something that we are hoping that would help.
Mm-hmm. Is it something you're working on right now?
Yes.
Hmm. What do you use if it's not a secret? Like what kind of technologies, what kind of approaches you try? It's a pretty interesting, and we because also we right now have this LLM Zoom camp, and perhaps this would be interesting for our students to also know what are the potential applications of LLM and AI.
I think the LLM space, the text to SQL space is quite well established. So that is kind of what we are trying to do now. Um, being able to use metadata from data warehouses and data catalog information from data catalog. We chunk them, we create a vector database from that, and then apply on top of it a large language model to be able to take in user queries in plain English and translate it into SQL statements before returning um, an output to the users.
Mhm. So it's some sort of a RAG application where
Yes,
instead of
spot
so
on.
you give
Yes.
extra information. So like you have a plain English query that is a subject matter expert creates, and then from that you create a prompt that this is the question from our user that you need to answer using the following context, and the context you give is all the relevant metadata information you get from the data warehouse, from catalog. Like this is the information about the tables. And using this information, the LLM can create a SQL query, which is then you execute and then you return the answer to the user. Is this how it works?
Yes. Essentially, yes, it's the process of using RAG.
So RAG, in this case, the database that you query with like the R part in RAG is the metadata information, right?
Yes.
Uh-huh.
So it
Okay.
allows the LLM to understand which table to refer to in order
Mhm,
to extract the right information.
mhm. And how often the queries it produces, the SQL queries, are not working?
Mm, I don't have a fixed number
Mhm.
for now
But it
because
happens, right?
it happens for sure. It happens. Um, I found that it goes a lot more with it. Apart from the rec portion, there's also the element of prompt engineering, whereby you need to either expose the model to sufficient examples of text to SQL combinations, so it knows for what type of query, what is the relevant SQL query that it can make reference to, and
Hmm.
also being able to, when you are querying a database, you want users to just be able to query. You don't want to include things like insert statements, update statements, or delete
Yeah.
statements for sure. Yeah, so there are additional safeguards that you need to make sure that doesn't get invoked.
Hmm. Yeah, that's a very interesting project. Yeah, and for me, I'm right now interested in maybe not collecting, but learning about as many use cases as possible, because this is a fascinating area. Like there are so many things we can do now with LLMs. Yeah, that's pretty cool that you're doing that too. Right now, it's in sort of some sort of alpha or early development state, right? What you do.
Yes.
Mm. Yeah. Um, but in general, how big the data sets? Like this is not the only project you work on, right? So there are probably other more established projects that you need to work on, like all the things we talked about, like when it comes to transportation, collecting this tape, tapping out data, right? Are these data sets large, or how large they are?
Yes, we collect a lot of information. So for fair cut data alone, in Singapore, we collect like millions of data per day of passenger flow. So this gives us a lot of data points because by analyzing fare card data, we can track passenger flows between stations, identify the peak travel times, and also access the popularity of different routes.
Mhm,
So then this allows us to go more in depth into things like route optimization or like fare structure optimization. So back
mhm,
to the topic about policy, right? By analyzing fare card data, we can help determine what is the optimal fare structure. So for example, in Singapore, we have the Public Transport Council, where one of the policies that was implemented was morning pre-peak fares, which allow commuters to enjoy savings if they tap in before 7:45 in the morning.
mhm,
So this essentially the intent is to shift travel demand away from the peak hours and
mhm,
alleviate train loading, because
mhm,
everyone is gonna want to hit the station at like 8:30, 9 a.m. and get to
mhm,
work. So by introducing this policy, we encourage people to travel early and pay
mhm,
less.
mhm. And these millions of data points that you collect, like how exactly are they processed? Like, do you use like the usual tools like Kafka and I don't know, like a data lake, data warehouse, or you have something specific? And like, how even data comes from the bus? Like, do you have some sort of transmitters there before they end up in your Kafka or whatever?
Yes, we have sensors on the bus that collects location information, and from the fare card systems, the gantries, we collect those data and it's stored
Is
in
it
a
it's real time? Like the moment I tap in, I already have an event somewhere, or like at the end of the day, you get the data from the bus.
the data is stored, but the aggregation happens afterwards, because in Singapore we have the concept of a ride and a journey. So for writes, we allow our fare structure is such that we allow you commuters to have multiple rides and make transfers between trips
Mm-hmm.
within a 45-minute period, and we consider
Mm-hmm.
that a journey. So then we compute the fares using distance. So hence we do not process it in real time. It
Mm-hmm.
happens after a time lag. So this allows us to like aggregate all this information
Mm-hmm.
before storing it in a data warehouse, and we use a
Mm-hmm.
combination of like Kafka and PySpark
Mm-hmm.
to
Uh-huh.
process the information.
Mm-hmm. But there's probably a thing that sends the events from the bus immediately to your system, right?
Yes.
Uh-huh. Okay, so you don't need to wait till the shift of a bus is over to actually, I don't know, connect to the bus and download the data.
Yes.
Right. Oh, that's cool.
Um,
Hmm. And then it's like Kafka, PySpark, all the usual tools that we use in data engineering, right?
yes.
Hmm. And you work there with this infrastructure.
Yes. Yes.
Did you ever need to go like on a bus to fix a sensor?
No, I haven't had the need to.
Yeah. Like it's pretty reliable, right?
Yes, generally it's reliable, but
Hmm.
I think in data engineering, there's also the aspect of being able to detect data quality issues and or like detect data anomalies. So I think that's another aspect of data engineering whereby we want to be able to know if a certain transponder on a bus transmitter on a bus is not sending data correctly. Yeah. So I haven't had to go down to a bus specifically, but I think that is one aspect whereby we are always, as data engineers, you always have to enhance in order to ensure that data quality is there.
Hmm. The Yeah, I'm just thinking what else to ask because like I'm kind of torn apart between like going down to the like traditional data engineering, but I'm also interested in the Gen AI applications. Um, so what do you want to maybe go deeper into?
We could go more into how AI,
Yeah,
into more into the AI aspect of things.
yeah. So do you have any other applications apart from that question to SQL thing?
Mm, that is the main thing that I'm currently working on, but I think increasingly there are there are generative AI applications that can be applied, whether is it to help create synthetic data for, because there are certain types of projects whereby we do not have the full scope of data, and generative AI can potentially be applied to create synthetic data for these purposes. On top of that, I think increasingly we may be able to think of generative AI as the new UI in terms of how people search for things, how
Mhm.
people um, look for information, because we may be increasingly more accustomed to using a chat
Mhm.
interface rather than going to
Me
a website and
definitely.
clicking on
Yeah.
multiple tabs to find the information you need,
Mhm.
and moving away from keyword search into more into semantic search. So I think there are a lot of applications for generative AI, whether is
Mhm.
it in the e-commerce space or elsewhere. It could shape the way we search for things to buy in the future. We may
Mhm.
not need to key in keywords. We could use a chat interface to discuss and get
Mhm.
ideas on what to buy for like maybe my niece's birthday next month.
Mhm. Yeah, I'm getting so lazy these days with like the ChatGPT and the like, because I can just use voice recognition. So I take my phone, I start speaking, then I click the button, and then it starts answering my question. Like I don't
Yeah.
even need to type. It's so convenient. Um, I'm curious about this synthetic data that you mentioned. Like my experience with LLMs when it comes to synthetic data, like I didn't experiment a lot, so I'm wondering how actually good it is when it comes to generating data. Like, I don't know, numerical data, like can it do time series or what kind of data you need?
Um, I think I talked about this in quite a general sense, but I just thought of Gen AI in being able to create synthetic data, especially when it comes to more complex or
Hmm.
nuanced data sets. Um, and also from a data sharing perspective, sometimes there's a need to either mask information, and Gen AI might be one potential way to share the information, but generate it in a sense that it is the sensitive or confidential information is being
Hmm.
masked.
Hmm. Because you release, the city of Singapore releases a lot of public data to like these open data platforms, right? And sometimes you need to edit this data before publishing.
The current data that we share are data that is collected from systems. Of course, we mask things like card numbers.
Mhm. What do you actually share? Like, and how to find this information?
There are two key platforms. One is data.gov.sg. The other one is called Datamore. So data.gov.sg aggregates information across different government bodies in Singapore, and it ranges from things like rainfall to air pollution figures. Um,
So there are categories like art and culture, education, economy, environment, geospatial, housing, health, social,
yes,
transport, real-time APIs. So I guess I need to go to transport to see your data sets, right?
yeah,
Okay, so I go to transport, and there is quite a lot of things
yes.
like
It
air
includes like
passengers.
air travel, geospatial data of like paths network.
And let's say somebody also in January will start the next cohort of data engineering. What kind of projects would you recommend for them to try using these data sets?
Mm, I think one useful data set could be car parking data because we collect car parking figures in I think if I'm not wrong, it's real time. So you get gantry transactions. So I think transaction data is quite a useful and
Hmm.
large data set for data engineering projects, whereby you can ingest the data in real time, store it,
Hmm.
store it in a data warehouse, data lake, and then process it later on for analysis.
Car parking. How do I find it? So I just look for car parking. I don't think I can find anything.
I think car parking is a dynamic data set.
Uh, there is real-time APIs. Maybe this is what
Yes,
I
yes,
I'm interested in. Okay.
yeah.
And I guess I would be interested in. I cannot find. Maybe you can send it later. This is not something I can just find right now.
Yeah, I can
Mm,
send to you later. Another one
mhm,
would be real-time taxi data, also
mhm.
another dynamic data set. Because I think the last data engineering Zoom camp, we were using the New York taxi data set. So
Yeah, we'll keep using it.
it is an aggregated data set, but
Mhm.
I think it would be useful to also look at real-time data set and like go through the
Uh-huh.
process on how to store
Yeah.
this information.
So I put taxi there in the search bar, and then I see public transport capacity, monthly taxi population, and there is data from January 2005 to December. This is not super up to date, but like it's up to December 2017. So there is quite a lot of data. But I see like there are many data sets with that are constantly updated, right? You sent me something.
Yeah, I
Thank you.
just sent it to you. There's another link specifically for transportation. So the under the dynamic data sets, you would find real-time car park availability or things like parking.
Yeah. What I'm doing right now is I'm putting this to our to the description, so you can check the description right now. I put the link. Yeah, thank you. Um, yeah, I don't see actually any questions from anyone? So let me check. I think I lost. So yeah, I run out of questions. I don't see any questions from anywhere. I'm just wondering. I have a few last ones. So if somebody wants to study what you do, are there any books or courses that you would recommend on this on transportation, geographical transport, on learning more about transport scientists, what kind of work they do, things like that, like other courses or books?
Um, I think the courses by DataTalks Talks Camp is a good primer, but also going more into specifically
Because
into
we use taxis, right?
urban. Yes. So I
Right.
think that is one very rare example on how to work with data and how to apply it in a real world context. So I think those are good use cases. Um, but also understanding more about the why behind why we do this kind of analysis. I think there are two books that kind of shaped the way I think about cities. One is The Death and Life of Great American Cities by Jane Jacobs. So this is a very classic book that provides a critique of urban planning and as well as her vision on creating how to create vibrant and livable cities through community-based approaches and also paying attention to human scale design. Another book is titled Happy Cities Transforming Our Lives Through Urban Design. So, this book blends urban planning with psychology and sociology, and it explores how cities can be designed to improve our happiness and well being. And I think this provides a very good backdrop into why we even bother to study taxi movement in the city.
Mm-hmm. Yeah, interesting. So the first one is Death and Life of American Cities, and the other one is Happy Cities, right?
Yes.
Okay, interesting. Well, I remember being in the States, and it's very difficult to get around without a car. Well, apart from New York and Boston, maybe.
Yeah.
Uh, so, yeah, I hope they implement some of the things we do in Europe or in Singapore. So then it's was I remember actually I was picked up by a police car when I was going there. So I was just walking. I Since I'm from Europe, I'm not used to, you know, having to have a car to get around. So I was just walking, and it was a road without any sidelines or pedestrians. So I was just walking down the road, and then a police will stop me, saying, "Hey, what are you doing here? Why are you walking? Why are you not in a car?"
That's funny.
Yeah. Well, anyways, Rachel, thanks a lot for joining us today, for sharing your experience with us. Uh, and yeah, I learned a lot new things. I had no idea that these things existed. So that was very interesting. So thanks for joining us today. And thanks everyone for joining us today too. It's been our first episode after a break. So yeah, it was great. Thanks.
Yep. Thank you for having me.
And yeah, happy to hear about your transition to data engineering and that our course helped. That means a lot to me personally to hear success stories like that. So yeah, thank you.
Yeah.
Okay.
Thanks for this.
Yeah. Well, have a wonderful rest of the day, and to you, Rachel, to everyone else, and see you around.